of the idea of entropy, which is, yes, represented by a capital letter S, but the entropy, it represents the amount of randomness in a system. So if you increase the entropy of a system, then you increase the amount of randomness. And the reason that some systems prefer to be at a higher entropy, greater randomness, is because it increases the stability of the system. Be able to define that entropy represents the amount of randomness or chaos in the system. You may be asked to look at an equation and identify if the entropy increases, decreases, or doesn't have any significant change. So the first thing I want to remind you to look at are the phases. What phases do you see on the reactant side versus the product side? So our phase of material that has the least amount of entropy would be a solid, whereas the phase that represents the greatest amount of entropy is a gas. We have two other phases we talk about in chemistry class, liquid and aqueous. So when a material changes from a solid to a liquid, the entropy increases. Our third phase is the aqueous. And an aqueous solution looks a lot like a liquid, but because there are more than one type of particles, aqueous solutions have a greater amount of entropy than a liquid. Now, if you're looking at an equation and all the substances and materials in the equation are all in the same phase, then compare the number of moles. So, more moles, more entropy. So let's take a look at a couple practice problems. So you are given a balanced equation. Here it is. Which statement is true? Well, notice that the first half is either endothermic or exothermic, and the other half is about the entropy. So I'm going to first look at the entropy. And I notice that I start off as a solid and end up with aqueous. Well, aqueous always has an increase in the entropy. So as we go from reactants to products, the entropy increases. So I can eliminate response B and response D because they both say the entropy increases. So now I have to determine if it's endothermic or exothermic. Well, this reactant, it is combining with this energy. So this energy is going into this reactant. So that reactant has to absorb in order to form the products. So this is best described as being endothermic. So A is the best answer. Okay, so which reaction has the greatest amount of entropy? First, we're going to take a look at phases. So we have liquid, gas, gas. Gas, 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 liquid, liquid, solid. So let's take a look here. So liquid to two gases, so liquid to gas, we can tell by the phase increase. Here we have everything is a gas, so let's hold on that. We have gas to a liquid, we see a decrease in the entropy. Liquid to solid, we see a decrease in the entropy. So now let's take a look. We have 2 moles heading to 3 moles. So this also sees an increase. However, the reaction that shows the greatest increase in entropy would be A, because here we have a liquid, so the molecules are touching, and in order for it to enter the entropy, we have a greater to a gas. Where here everything is a gas and we're causing it to spread out. Looking at this one, the entropy of a sample of water increases as the sample changes from Gas to liquid is a decrease. Gas to a solid is a decrease, becoming more ordered. Liquid to gas is an increase, greater randomness. Liquid to a solid, decrease. So we want one that has an increase. So it looks like our best answer is C. And our last question here. As the reactants form the products, the entropy of the system. Well, I see that on the reactant side I have a gas, and on the product side there's only one solid. So I'm going to just take a look at it as gas to a solid, so the entropy has decreased. The last part of this page is the driving forces of change. So all around us we have natural changes, physical, chemical, and nuclear changes. And all of these changes happen out in nature so that the system becomes more stable. The driving force why each of these types of changes happens is to increase the stability, meaning whatever the product side has means it has less effort or less stress to maintain. So entropy, what requires less stress or effort to maintain? Perfect order or a little bit of messiness. So a little bit of messiness takes less stress to occur or to maintain. So higher entropy is a driving force. Now the amount of energy, think of like sprinting versus walking slowly, which requires less effort or less stress to continuously maintain. You can't stay at a sprint at all times. So what is easier to maintain, less effort, less stress, would be a lower energy state. So get these ideas memorized.